we're continuing with cell biology and life science in a nutshell. So, we're learning about a molecule which is created in the smooth endoplasmic reticulum of cells called steroids, which lipids and steroids are made on this organelle, the smooth ER. In prokaryotes, biosynthetic pathways exist for the tetracyclic steroid framework. For example, in mycobacteria, where its origin from eukaryotes is conjectured, and the more common pentacyclic triterpenoid hopanoid framework. So these are some specifics about the molecule, steroid molecules. So all steroids have four rings, six carbon rings, and one 5-carbon ring attached. Everything else is a relation in the molecule and determines what its function is exactly. So I have some examples as well for the different kinds of molecules in this group. So the tetra, let's see, 17. Most of them, I guess, have 17 carbons. So the parent. So these four rings have 17 carbons total. So that's the main framework of steroid molecules. So gonane has no alkyl side chains. Or wait, that's this one. And then these ones, steroid 5-alpha and 5-beta stereoisomers. The two isomers are defined by a difference in the side of the large planar ring system that the hydrogen atom at carbon 5 is attached, and a resulting change in the conformation of the steroid A ring. Right here. Shown are the four rings most common to steroids with standard ring labels. So A, B, C, and D for the 4 carbon rings. And the R at carbon 17 represents possible side chains at that position, so which can be a variation. The two isomers are drawn in line angle representation of, so like from the side view, in the chair envelope form. Rings A, B, C, and then ring D. Okay, projected onto the plane of the page in horizontal orientation of the ring system with bonds extending above the plane of the page to terminal methyl groups. So CH3 groups methyl, and hydrogen atoms indicated with bold lines. Those extending below the plane of the page are in cross-hatched lines. So 3D, you can imagine. Only the hydrogen atoms at the tertiary carbons are shown explicitly. All remaining hydrogens in the line angle representation are implied. So they're not shown. Alternative representations of these extending bonds are as bold and cross-hatched wedges, respectively. So this is an example of a steroid called testosterone, which is the principal male sex hormone, and it's an anabolic steroid. So its side chain is the hydroxy group, OH. This one is progesterone, a steroid hormone involved in the female. It is involved in pregnancy, embryogenesis, and that reproduction. And its side chain is this one right here. Oxygen, hydrogen. Okay, and this one's cholesterol, a typical animal sterol. Which is the structure, lipid, and key steroid biosynthetic precursor. The long chain, side chain. This is a cholecalciferol, aka vitamin D3. So it looks a little bit different. Here we have a 3D representation. Dihydroprogesterone, also a steroid. The shape of the four rings is illustrated. Carbon atoms are in black. Oxygen is in red. Hydrogen is in gray, light gray. The apolar slab of hydrocarbon in the middle, so the darker black. The polar groups are in red. So this is a common feature of natural steroids. So nonpolar in the center with the carbons and the rings, and the polar oxygen and hydrogen in the outside. So there's an endogenous steroid hormone, a biosynthetic intermediate. That's showing it in 3D. And then here we have the simplification of the end of the steroid synthetic pathway, where the intermediates isopentenyl pyrophosphate, or PP or IPP, and dimethylallyl pyrophosphate, DMAPP, form geranyl pyrophosphate, as well as squalene and lanosterol, the first steroid in the pathway. Simplified schematic diagram of the sterol biosynthesis. Several intermediates have been omitted. Compounds depicted are the dimethylallyl pyrophosphate, isopenyl pyrophosphate, geranyl pyrophosphate, etc. Steroid structure. Steroids can be classified based on their chemical composition. So depending on how many carbon atoms they have total determines what is their class. If you have 27 carbon items, this is called the class of cholestanes, which is an example is cholesterol. 24 carbon atoms are the cholanes, example is cholic acid. 21 carbon atoms is pregnanes, example progesterone. 19 carbons is androstanes, for example testosterone. And 18 carbons esteranes, for example estradiol. So steroids can be classified functionally. The major classes of steroid hormones with prominent members and examples of related functions are shown. So corticosteroids, glucocorticoids, cortisol, a glucocorticoid whose function include immunosuppression. Mineralocorticoids, aldosterone, a mineralocorticoid helps regulating blood pressure through water and electrolyte balance. We'll continue in the next part.